Good day. You should have PowerPoint notes that are fill in the blank and look like this. They say Stoichiometry Intro. And here it's reminding us that chemicals do not combine according to their masses. It's all about particles. So that means we can get down to the single molecule and element and things like that, atoms as they react and produce products. But we can also do it in terms of moles, because moles is our counting device for dealing with these crazy particles. So when we say they don't combine according to their masses, we can't do direct calculations according to masses. We first have to take any masses and convert them into moles. So it means you got to remember stuff from chapter 4. So here we have an equation, and we want to express what it means in a number of forms. So we have magnesium and hydrochloric acid makes magnesium chloride, which is soluble, and bubbles of hydrogen gas will fizz away. So it's saying according to our balanced chemical equation, and Stoich always starts with a balanced chemical equation, you can see it's 1 atom magnesium, 2 molecules of hydrochloric acid, 1 formula unit of magnesium chloride, and 1 molecule of hydrogen. Well, if we count in terms of particles, we can also count in terms of moles. So we can go 1 to 2 to 1 to 1. And that's generally the level we'll operate at. But we can't simply say, oh, we got a gram of this, 2 grams. That simply will not work. And that's why there should be a big X across your notes. So it's got to be either in particles or moles of particles. Well, let's try to illustrate what's going on. Just remind you about a balanced equation. 1 magnesium, 1 magnesium. Here we have chlorine, another chlorine. 2 there, and then we have hydrogen. Hydrogen gives us 2 hydrogens. And you can see that's why we needed 2. We needed 2 hydrochloric acids to balance this equation. So that's looking at the particle level. Now what we're saying with this is if I know how much magnesium is reacting, I can figure out how much hydrochloric acid it's going to react with, and I can figure out ideally how much product it's going to make. Or I could look at the magnesium chloride and see how much of the reactants I need in terms of particles and how much hydrogen would be produced as well. So that's what we're going to be doing. We're going to be moving around using the balanced chemical equation into the land of moles. Now, what have I done here? Well, I've said, hey, if I have 4 magnesiums, before I had 2 hydrochloric acids, but you'll see now I have 8 of them. So this went up by a factor of 4, this went up by a factor of 4. So now I should get 4 MgCl2s and 4 hydrogen molecules. They're still behaving according to these what are called mole ratios, the ratio of coefficients. But they're still in that same proportion, 1 to 2 to 1 to 1.